We're going to simulate the execution of the following Python program. Beginning at the red arrow, we're assuming that we're about to execute line 20. Now, before I start drawing anything, I'm going to make room on this tablet for some global space and for some heap space. Line 20 begins with a call to this constructor here. At the end of the constructor, we have now created an object of type point2. Its identifier is the return value of the constructor. Looking back at line 20, we can see that we're going to create a global variable called p, and it's going to be initialized with the value id1. At this point, we have finished executing line 20, and we can now move on to executing line 21. Line 21 is essentially a repeat of line 20, except this time we're going to create a point with x-coordinate 2.0, y-coordinate 3.0. We'll need a new identifier, and that will be the value that we place in the new global variable q. And now we're ready to execute line 22. Line 22 calls the function farthest from origin. This is our first function call, and so it's a good time to create our call stack. We'll begin by drawing a call frame for the function farthest from origin. The arguments we passed into farthest from origin are p and q. These arguments have the value id1 and id2. These argument values become the values for the parameters a and b. And now we're ready to begin the execution of the function farthest from origin, beginning at line 14. Line 14 is our third call to the point2 constructor, and so we should be very familiar at this point with the fact that it's going to create a new point2 object with x and y coordinates 0.0, and we're going to create a local variable origin inside the call frame whose value will be the identifier of this new object. We have now finished executing instruction on line 14 and can move on to the instruction of line 15. Line 15 is going to make two calls to the function dist square. The first call passes in the arguments origin and a, which inside of the call frame for dist square will be the values for parameters a and b. We begin executing this function on line 10. This line has us look at point A's x attribute, take that value, and subtract from it point B's x attribute, and then square that value. We then look at point A's y attribute, take that value, and subtract from it point B's y attribute, and square that. We add the two numbers together, and this is the return value of this function. When we return from this function, the call frame goes away, and the return value 5.0 is returned to the function that called it. We're back to executing in the middle of line 15, and the next thing we have to do is make yet another call to distance squared. This time, the two arguments to the function are origin and b. Inside the call frame for distance squared, these two values will be known by the parameter names a and b. Once again, we begin executing this function on line 10. And once again, we're going to look at point A's x-coordinate, subtract from it point B's x-coordinate, square that value, look at point A's y-coordinate, subtract from that B's y-coordinate, square that value, and this gives us the return value of the function. Now we've finished completing line 10 of the function. We can return from the function. We remove the call frame, and the return value 13.0 is sent back to line 15, where we can now evaluate whether 5 is greater than 13. Since it is not, we will move down to line 17. This has us go into the else clause of line 18, which tells us that the return value of this function is the value of b. When we execute line 18, this returns from this function call. We erase the call frame for this function call. And now we need to complete line 22 of our code, which creates a global variable called r, and the value that it gets is the return value from the function farthest from origin, which is the value id2. And now we have completed the last line of our code, line 22. At this point, we have no active call frames because we're not in any function call. And the final state of our memory looks like this. We have p, q, and r as global variables, and we have the 3 points that we created that are still present on the heap.